Line focus principle. First, before learning line focus principle, let us learn what is focal spot. It is area where the electrons bombard or strike on the target anode. Means the electron which is produced by the cathode goes and hit the anode. That is the area known as focal spot. As you know that when it hits, dislocation and X-rays are produced, but 99% of it is produced as heat and only 1% is produced as X-rays. Therefore, it's a problem. Large focal spot, therefore, there will be large heat distribution which will happen, which is very useful because the heat which will be produced on the large focal spot area will be distributed on the large area. But bad image. If there is a small focal spot, then the image will be very good, but heat will be very less and not able to distribute properly. Now we need a large focal spot for large heat distribution and small focal spot for good image. We need both. Now this problem is solved by line focus principle. Now let us draw the diagram. First cathode, anode. From cathode, electron goes, hit the anode at the focal spot, X-rays are produced. Now because of which of the line principle, focus principle, there is tilting of the anode. Now because of this tilting, electrons will be bombarded over the large area, but when we will view the X-rays, this area will be small, which we will see in subsequently how we have to find the image. Again we will draw a diagram. First cathode, anode. From cathode, electrons are produced, hits anode to the focal spot. From that, X-rays are produced. Now when X-rays are produced, that area will be labeled as apparent focal spot, and that focal spot which was there. Now compare the size of that apparent focal spot and this. The apparent focal spot will be small, whereas the focal spot will be large. Therefore, in line focus principle, to achieve it, we have to tilt the anode, and the angle which is tilts is given by sine theta. Lesser the sine theta, there will be lesser of focal spot. Now next effect is the heel effect. Now, what is heel effect? It is the disadvantage of handling the anode. We have tilted the anode in line focus principle. There is a disadvantage which is known as heel effect. What is heel effect? It is the variation in X-ray intensity along the anode and the cathode end. Let us see in the diagram. Cathode is there, anode is there. From the cathode, electrons are injected, hits the focal spot on the anode, X-rays are produced. X-rays are produced in the fan shape along the anode side, marked by the circle. Those X-rays will be absorbed by the anode. Therefore, there will be variation in the intensity of X-rays on that fan shaped beam. This is known. Therefore, because of heel effect, along the anode side there will be absorption of the X-rays by the anode, therefore decrease in the intensity of X-rays. What is the advantage? It is in mammography. The thicker part is the chest wall and the breast tissue is the thinner part. Since thicker part it is kept at the cathode side, therefore more X-rays will come. Therefore, thicker part is on the cathode side. And in AP view of thoracic spine, the lumbar region is thicker, which is kept on the cathode side. Since it is thicker, more X-rays of the cathode will pass through that area, and the thinner side, anode, less X-rays will be passed. Therefore, this is the advantage of heel effect